Well, hello again everybody. Well, I thought today we could go ahead and we can do the alignment on the receiver section of our Cobra 19 GTL radio. But before we do that, I'm sure that you and my twiddling stick are really glad to know that we've gone ahead and we've actually found a piece of ferrite core material, and I'm hoping that it is going to fit into our 50 megahertz trap here. Now of course I don't know if this is the right type of ferrite material because there's lots of different types. I only just found this floating around in the bottom of a box of ferrite, so I don't know if it's exactly the right material to use, but this is what we've got, so let's install this and give it a go. Okay, so you can see on the right hand side of the spectrum analyzer displayed the return of our naughty 54 megahertz harmonic signal, so let's screw in this ferrite. And with a bit of luck it should reduce. So I'm screwing, still screwing more, screw, lots of screwing going on. Come on, screw. Oh, there he goes. Well, I was aiming to get 60 dBs down, but I think we're pretty much back into the noise there, so I'm going to call that done. That's certainly an awful lot better than it was before. So off camera I've gone ahead and I've just realigned the final output stage again, and I've got to admit I didn't really get any difference of adjustment out of it. This radio is quite capable of producing more than a 4 watt output, but according to the manufacturer's instructions we have set it to 3.8. So I'm just going to squirt some wax on here just to try to seal this. So I think for the transmitter side of the alignment we're going to call that done, so let's just quickly run through the receive alignment. Now I'm not expecting any problems here, but well, who can tell? So aligning the receiver section is really quite similar to the transmitter section in that we've got various Tocco coils here, so we've got L1, L2, L4, L6 and L7 and L8. We've got to tune them up. And you can see that on top of 3 of these Tocco coils here, I've actually stuck some blue tack on them, and there's a reason for that, because I just had a quick go off camera at doing the alignment just to practice, and well, I actually managed to get my twiddling stick into the wrong hole, and well, we all know what that's like. It leads to all kinds of difficulties, doesn't it? So I have gone ahead and I've just stuck some blue tack on top of these just to remind me that I don't want to stick my twiddling stick into them. Now historically, when I used to do this type of alignment without a test set, I would actually just connect a voltmeter to the audio output, to the speaker output for the radio, and effectively just adjust it for maximum smoke. But we have got a test set, so we're going to have a go at using that. And I think the other thing that I'm going to just have a go at using is the cyanide meter. Now the advantage of using a cyanide meter is that if you just use the kind of peak power method, all that's actually showing you is the peak audio power, whereas a cyanide meter, well, that actually considers the signal to noise ratio, so it's signal to noise and distortion. So I actually think that's in some ways more important figure. It's alright having a very loud signal, but if it's distorted to hell, that doesn't really help you. So if you have got a cyanide meter, it's probably a good thing to use, but if you haven't got a cyanide meter, you would just tune for maximum smoke on the audio output. Okay, I think that's around the maximum. It might have come up slightly. The problem with cyanide meters is they do tend to bounce around quite a lot. So what we'll do is we'll do the alignment once and then we'll go back and repeat it. So that was core L1, so next I'm going to do core L2. What we might just do is just drop the signal level down a bit more. So the next one that I'm going to do is L4. Okay, I think L4 was fairly well peaked, so L6 now. Okay, I think my hand capacitance is having a little bit of an effect. Next one is L7. Again, I think L7 was really fairly well peaked. And finally we're going to adjust core L8. Okay, and that's bouncing around quite a lot. I don't think I've really managed to adjust that very well. And again, if I just put my hand near the radio, it's actually just picking up some hand capacitance, so it's a little bit tricky to align that one. Just going to go back to L1 and just repeat the procedure and just see if we can improve on it, because some of these adjustments are a little bit interactive. So let's go ahead and take a proper cyanide reading. Okay, well, running the automated synad test, that's coming up about 112 dBm for 12 dB synad, so that actually isn't stunning performance. Sorry, 112 dBm's round about 0.5 of a microvolt, and I was hoping to get quite a lot better than that, but that's what it is. Well, I've got to admit, I didn't have great success then using the synad method, so what I'm going to do is I'm going to follow the instructions in the manual and really just do the peak power tuning for the audio output. So you can see I've gone ahead and I've got out this FET micron-to-meter, and Simon Spears has been banging on about how good these micron to FET meters are for ages, so I thought we would give it a test. So if it doesn't work, it's all Simon's fault. Now, one of the features of this meter that Simon points out is it's actually got a zero adjustment range, so you can actually center the needle anywhere where you want to. So what I'm going to do is I'm going to use this meter as a galvanometer, which basically means we set the needle to the center position. So let's go ahead and let's have another go at adjusting L1. Now, I've got to admit, it's far easier looking at the needle on this than looking at the digital meters on my Stabilock, because they are just very slow, sluggish, and they're a bit unresponsive. You actually tweak the pot, but it seems to take a while to update on the actual measuring equipment, and I think that can be quite confusing. So we've set that. What I'm going to do is I'm going to re-zero it. So I think I had that pretty well peaked, didn't I? So I'd not get any improvement on that one. L4. Okay, it looks like I had L4 pretty well peaked. L6. Nope, I think I had L6 well peaked. L7. So I did have L7 pretty much spot on, and let's go for L8. Well, I think I had L8 pretty much peaked as well, so that's as good as I can get it. So let's go ahead and just do a synad reading again, see if we've improved anything. I suspect it's actually probably got a bit worse. Okay, so using the peak tuning method rather than the synad meter, that's actually a little bit worse, because that's 111 dBm for 12 dB synad, so that's more or less about 0.6 of a microvolt, so it was nearer to 0.5 before, so we've actually made things worse. I did expect that would happen, but still, it's not a totally bad way to do a peak and tune, and if you haven't got a synad meter, I'm sure it's perfectly acceptable. So I'm going to go back and have another go using the synad meter, just see if we can slightly improve on that and get back to our 0.5 microvolts, and then I'm going to call it done. So I'm hoping that somebody who's a bit more experienced than me working on these AM sets will maybe just comment on whether that's a reasonable figure or not. That's certainly the best I can do. So the next adjustment point is the RF gain, which is VR7. Now, I think this works by actually adjusting the negative feedback being applied to the second IF stage. And I've got to admit, I've had a go at adjusting this already, and I haven't done too well. So what the instructions say is we've got to adjust VR7 for a 2 volt output with the signal generator set to 700 microvolts. So I'm guessing here that they mean 700 microvolts EMF, because of course they never tell you in these instructions, but I think for CB stuff it usually is EMF. So that means we actually need to set the signal generator to an output level of 350 microvolts. Now that's a hell of a big signal, that's a very high signal. So I'm going to go ahead and I will just show you what happens when we do that. Now, for no particular reason but the Marconi signal generator was feeling quite unused and rejected, I've decided to give it a bit of a go. So we've got the carrier frequency here set to channel 19, which is 27.185. We've got 30% modulation depth, and what do we need to set? Well, we've got to set it to this massive figure here of 350 microvolts. So having just plugged my signal generator in, that's an absolutely massive signal, which is, well, it's plus S9 on my meter reading here. So that's a very big signal now. So in theory we should be able to adjust this this potentiometer here to get a 2 volts output RMS on the speaker. So I'm going to use our microntometer again. It does specify that we need to test it into an 8 ohm load, so here's my 8 ohm load. So I'm just going to disconnect the external speaker. I'm going to plug this meter in instead. I'm going to turn the volume up. And well, part of the problem immediately is that we've got this meter set to the 30 volt setting here, and well, what reading is it reading? Let me just check that. 30 volts. In fact, this is why I hate this meter. So where's the 30 volt scale? Is it that one? 3? So for this meter, the AC scale is the bottom one here, and it's actually really compressed into kind of the bottom half of the meter reading, which I do actually think it makes this meter a bit of a pain to use. So it's actually showing about 8 volts at the moment. So what we should be able to do is just adjust this variable resistor here, and we should be able to turn that down to 2 volts. And I can't. It really has absolutely no effect. And in some ways I'm not particularly surprised, because I don't think you could produce enough negative feedback to actually defeat this massive incoming signal. So as I said earlier, I'm really not an expert on CBs, but I suspect there's something wrong with these instructions. I think the radio is actually working right. I can sort of demonstrate that by just reducing the signal level to something a bit more reasonable. So I have to admit I am at somewhat of a loss to know what to adjust the RF gain to this too, so I think I'm actually just going to adjust it about halfway. I found that it hasn't made a massive amount of difference to things like the cyanide reading, and even with very, very low signal levels set, you turn it right down and you can still hear the signals. So it's almost as though it doesn't have enough range, as though it isn't applying enough negative feedback and reducing the gain of the second IF stage. But I'm not exactly certain how this works. So it could be that this is just how the sets are. It could be that I've got there's something wrong with my test setup, and I really just don't understand it. So perhaps anybody who's worked again on these Cobra 19s and done this RF sensitivity adjustment, perhaps you can give me some advice on that and point out what I'm doing wrong, because it's quite likely I am doing something wrong. So our next adjustment is going to be our squelch level. So what it's asking us to do is we've got to, well, it talks about again adjusting for 2 volt output with signal generator, well, this time set to 1000 microvolts. Well, I don't really know why we want a 2 volt output. Surely we just want to know whether the squelch comes on or not, because you know the squelch should be on or off. So what we're going to do is, it says 1000 microvolts. It leaves us guessing whether that's EMF or not. As I said earlier, I think it will be EMF, which for my benefit and your benefit, that's going to be 500 microvolts PD, because that's what my signal generator works in. It outputs things in PD, or that's really fairly close to minus 53 dBm if that's how you want to work. So connect up the signal generator and inject a level of 500 microvolts. Before we do that, let's just check the squelch level first. And now that I've increased our signal level to 1000 microvolts EMF, even if I turn this squelch fully up, it doesn't actually cut out the audio. So we need to just adjust this till it does. So I like to turn the squelch fully up and then back it off a little bit. Okay, I'm fairly happy with that now. So that's our squelch adjustment done. So our final setting and the final thing we're going to do today is we just need to adjust the meter signal strength to S9, which is going to be, we're going to adjust this to 50 microvolts PD. Again, it says in the instructions 100 microvolts, so 100 microvolts EMF is 50 microvolts PD, which is about minus 73 dBm, again for those who like to play in dBm. So I think that our signal strength meter's perhaps just reading a little bit on the low side, so I'm just going to increase that. So we've adjusted the meter needle there to the S9 marker. These things don't have to be exact, they're all fairly arbitrary, these S9 signal meter readings. That'll do.